Welcome to this video on the third lesson in the particles and energy scheme of work. This is about energy stores, and there's really two main objectives to this lesson. The first thing that you want is for students to just be familiar with the five most common energy stores and be able to name them and spot them within concrete situations. The second part of that, which is linked, is to be able to identify events and work out what the energy store was before that and what the energy store was afterwards. Now, energy is a really tricky topic. I've had so many discussions with teachers about energy, and it seems like such a minefield because obviously we used to have this language of types of energy. Now we have energy stores and pathways. We kind of mix them up. I mix them up as well. Sometimes I talk about types, sometimes about stores. And I think the main message is don't worry too much. I think people worry that they're getting it wrong somehow. Really, what these, I think it's 4 lessons in the scheme about energy, what they aim to do is just get students to a point where they can read a description of a concrete scenario. Let's say a bullet is fired vertically upwards from a gun, and just identify the energy stores at different parts of that scenario. So, be able to identify that the bullet starts with kinetic energy and ends up with some gravitational potential energy, something along those lines. Because actually, if they can write those energy transfer equations consistently, by the time they get to key stage 4, then they're going to put some maths on and do the kind of half mv squared, mgh, all of those equations. And actually, the difficult part, the physics, which is what we cover in key stage 3, is just identifying what stores are present. Because once they've got the equation, then it's just maths. But what we want to focus on in this scheme of work, in these 4 lessons or so, is just identifying those stores and being able to spot them in concrete situations. So this first lesson starts by introducing the main energy stores. Now, the way I was used to do this was just to draw some pictures of a ball moving around or something being raised above the ground and then label it as kinetic or gravitational. And it always felt like that was a bit pointless. And actually, I think what is more helpful is to give students a sense that energy is this weird thing that doesn't really exist. And I think this is why it causes so many problems with teachers as well, because it isn't actually a thing. And I think the best analogy to use for you and for your students is that energy is a bit like money. So it's this, the definition of energy is a capacity to do work. It's kind of an exchange thing. So it moves around and allows different things to happen. And again, I'm already hand waving because it is a difficult thing to talk about. But what I might explain to my students, or what I might start with, is just start with this idea of money. So if I write money in here like this, and all I'm going to say to them is, well, look, there's 2 things that we can do with money. We can save it in the bank, or we can spend it. Which means to use it to do something, whether that's, buying clothes or going to the cinema or going on holiday, whatever. We either have it in the bank, we save it, or we're using it, we're spending it. Obviously, there's a lot more things you can do with money, but for the purposes of what we're talking about today, that's a pretty simple picture that we can give. Now, what I would do is side by side, so they can compare this, is lay a similar diagram about energy out as follows. So I'd write energy. Well, there's 2 ways of thinking about energy, two kind of 2 ways energy can be stored, let's say. And this is where the language of stores is a bit weird because when you store, it's a bit like putting it in the bank. But anyway, bear with me. So the point is, there are 2 ways we can think about energy. One is potential energy, and the reason I've laid it out like this is because what I'm going to say to students is any potential energy is like energy in the bank. So it's not actually being used at that point, but it's ready to be used. And we'll look at some examples of potential energy stores in a minute. And then I'm going to call the other one, the other kind of category, as actual. And interestingly, in the early days of the science of energy in the 1800s, quite often this dichotomy between potential and actual energy was used, and what we now call kinetic energy was called actual energy. We don't need to worry too much about that. The point being here is it all comes back to kinetic energy, and that thermal energy, which is the other main one, really that's just kinetic energy of particles. So this is why I've used actual just as a broad category, so we don't confuse it with kinetic, but it's really the same thing. So again, the point here about actual, this is when we're using energy. And what we want students to see is, and this will be really, really helpful when they get to doing thermodynamics or the particle model of matter unit in GCSE, they need to see that there's these two ways we can think about energy. We have this energy that's kind of being saved, it's in the bank, it's ready to be used, and that's potential energy. And then we have this energy that is actually being used, the actual energy, and that's like spending money. That's actually doing stuff with that energy. And what I might do under here then is just list some of the more common ones. And again, I used to draw diagrams for this, but really all you're doing is illustrating. So you possibly don't even need to waste your time doing that. What might be helpful in this lesson is some sort of a demo, you know, throwing balls up and down or squeezing them, bending rulers, stretching elastic bands, rubbing your hands together for friction and thermal energy, all of those sorts of things. You will be the experts on that, but this is maybe a helpful way to lay out how we think about energy to illustrate an important distinction that comes in later on. So again, what I might write here is, well, okay, we've got gravitational potential energy, we've got elastic, and I would give some examples of these as well. So I talk about burning a match or burning petrol or something like that, and that's chemical potential energy store. And then our main two, what I've called actual energy stores, I mean really the only one is kinetic, but for the time being we can talk about thermal energy as well. Hopefully by the end of the unit they'll be starting to get a sense that it all comes back to kinetic energy of particles anyway. So this is how I would introduce the main energy stores, and then you'll see in the slides there's just a few really simple questions, which is just identifying energy stores. Nothing revolutionary there. Now in the second part of the lesson, it's trying to use these ideas and use these energy stores that we've just given them, relating them to concrete scenarios. So that second part of the lesson requires a bit more thinking. And what I start with is the example of an elastic band firing a pen lid. I don't know why, I think it's just what I happened to have to hand when I was doing it, but it's quite a nice example. You can demonstrate that and really get students to think about, because when we think about energy as physicists, we're imposing that structure onto whatever's happening in the real world. So we as physicists decide what the events are and at what points we wish to consider them. And you get all sorts of problems later on, like, I don't know, climbing up some stairs. Well, you start at the bottom with less gravitational potential energy. Maybe you've got a chemical energy store. You walk up the stairs to the top and you've now increased your gravitational potential energy store. Students will always ask, well, what about in the middle when you have this kinetic energy store? And it's, as physicists, we choose what stores we want to consider. And actually, for the purposes of the calculation, we kind of ignore that kinetic energy store. We can just think about what happens at the bottom and what happens at the top. And this is why this exercise, I think, is useful. So what I would do is sketch a kind of before and after. And really, in these sequence of lessons, we want to get students moving from words and pictures, let's say, to those energy transfer diagrams. So I might just sketch a pen lid like this, and what I want them to identify is, if you've got this stretch pen lid, this stretched elastic band with a pen lid or whatever. So let's sketch a pen lid in here like that, and this is, you might want to label this as being stretched. If I can find a ruler. So you could add an arrow in here like this. Whoops. Say this is stretched. What we want them to identify is that something happens the moment you let go. And that is the really critical moment that we want to think about as physicists. So at the moment you let go and the pen lid starts to be propelled like this, so let's say, and the elastic band is now unstretched, let's say, but that is moving. And this is just a really simple example, but I think that's fine for year 7. So unstretched. What we want them to see is that something has happened. And that is what we're interested in as physicists. So it's identifying what that event is, that moment that you stretch it and then you let go. That's the important event. And then all we want them to do is identify in this lesson, well, okay, how was this storing energy? Well, it was stretched, so it must be elastic potential. And I'm not even going to draw arrows in this lesson. We're going to get onto that later. I just want them to identify the energy stores. And I'm always going to write the energy store, but also where it's stored, so that's in the elastic band. And then afterwards, what I want them to identify is, well, now this is not stretched. So this is not storing, the energy is not being stored in the elastic band, in the elastic potential energy store anymore. That is no longer happening. Now we've got a kinetic energy store, and that's in the pen lid. And what you'll see in the lesson is this is one that you would model and just go through that thought process, show them how you think about, okay, in this real life scenario, what is the energy store and where is it, in what object is it being stored? And you'll see there's just a few kind of multiple choice questions, and then there's a big table with lots of different examples. And you might want to use whiteboards to do that or something like that. But it's really getting them thinking about how these energy stores apply to those concrete examples. So we'll look at similar examples to this and draw energy transfer diagrams for them in the next video.